When I first worked on the problem of setting cell value colors to red, I was not aware of text content, and I really hadn't focused on the rows and cells properties. So my solution then was quite a bit different from the one I arrived at in the previous session. Still, my approach had some benefits. It introduced the document.getElementsByTagName function and introduced some JavaScript constructs that have wide applicability. The switch statement, including case and default, and the break statement. So I think there's still some value from this approach. Let's have a look. Recall, we're working with our inventory page. So there it is. And our objective here is to compare the value in column 3 to the value in column 4. And if column 3 is less than column 4, then set the text in column 4 to be red. Now, the cells we want to access are all TD cells, cells that have data. But each row has 5 TD cells. How to distinguish? We can't use the ID attribute. No IDs are assigned, and adding that would be a useless task if the table changes frequently. Each TD has a class attribute. Now that might be hopeful. But the cells in a row have class pno, desc, num, num, and num. How to distinguish amongst all the cells with class num? Well, we can keep track of them as we run through all the TD elements in the table. For each row, there will be 3 consecutive cells of class num. Ignore the first and extract the values from the second and third. So we start by gathering the entire collection of TD cells. All TD cells equals document.getElementsByTagName, parenthesis TD. Note that document.getElementsByTagName, parenthesis tag, returns an array of all the elements of type tag in that document. Next, we need to step through the array of TD cells looking for those with a class of num. So to start with, we set up this construct for I equals 0, I less than all TD cells.length, I++. If all TD cells bracket I dot class name equals num, then do something. Note the term class name is used instead of class because JavaScript has class as a reserved keyword. Now, we'll use a variable, num with the value of 1, 2, or 3. That is, if num is 1, this is the first of 3 cells with class num. If it's 2, then this is the second of 3 consecutive num cells. And if it's 3, then this is the third of 3 consecutive num cells. So we build logic like this. Initialize num to 1. Step through the cells array, and when you encounter a cell with class num, if num equals 1, ignore this cell and set num to 2 for the next iteration. If num equals 2, get the value from this cell into onHand and set num to 3 for the next iteration. And if num equals 3, get the value from this cell into onOrder and set num to 1 for the next iteration. And compare onHand and onOrder to see if onOrder needs to be colored red. Note, num is not an index or a counter. It is a 3-value switch with possible values of 1, 2, or 3. So our logic is looking something like this now. We set num to 1, all TD cells equals document.getElementsByTagName, parenthesis TD. For I equals 0, I less than all TD cells.length, I++. If all TD cells bracket I dot class name equals num, then some logic to get the values into onHand and onOrder. Then we can ask if onHand is less than onOrder and all TD cells bracket I dot style dot color equals red. So we're making progress. Now, given this setup, we handle the question mark code simplest with the switch JavaScript statement. So Here we are, the switch statement. Syntax, switch on expression. Braces, case value statements, and so on, possibly default statements. Expression is a variable or any JavaScript expression. This expression is evaluated and the result compared to the values in each case clause. The value on each case clause is usually a literal value, but it could be a variable or other expression. Note, for the value to match expression, both must be of the same type and have the same value. Note also that value is followed by a colon. Statements is like a statement block for if, without the braces. These statements are executed for those cases where value matches expression. Default is an optional clause, and if present, its statements are run if none of the case values match the expression value. Note that all pieces below the switch are bounded by braces. Now, one problem. Once a match is found, the statements for the matching case are run, as are all following statements. Probably not what you want, although it could be. To stop the execution of statements we don't want to run, we introduce the break statement. The break statement kicks you out of the current loop. For is the only looping statement we've seen so far, or switch statement. So you typically see switch, expression, case value, statements break, case value, statements break, and so on. Note, if the switch statement appears in a function, a return statement could be used to exit both the switch and the function. Note, a break statement can take you out of the innermost containing loop of two or more nested loops. For example, in this example, the outer loop is stepping through all the cells in the table. For each cell, the function gets the length of the content of the cell, and then the inner loop steps through all the characters in the current cell. And once a lowercase g is located in the string, the break statement kicks the flow out of the inner loop, and the code iterates back to the next cell in the outer loop. Also, you can use a labeled break. This names the label on a containing statement, and the break will jump to the end of that statement. In this odd example, in the inner loop, we count the number of lowercase o's in the current cell, and if the number is greater than 2, the break kicks us all the way out of the outer loop. In other words, once we find a cell whose content contains more than 2 o's, we're done. A label is a string followed by a colon. The label identifies the following statement. For a labeled break, the break statement must be nested within the statement that is labeled. Now, armed with this information, we can finish our function. We initialize num to 1. We get all the TD cells from the table into this variable, so we can loop through the entire collection of TD cells. For each one, we ask if the class is num. If not, we go get the next one. And we can ask if the class is num. Sometime we find it is, so we use switch num to see what's in num. If it's 1, we set num to 2 and break, which sends us back to the top of the loop to get the next one. Again, is the class num? This time it will be yes, so we say what's in num? Is it 1? No, it's 2. So we extract on hand from the current cell and set num to 3 and break, which sends us back to get the next cell in the list. And again, we ask if the class is num. We go into switch num. What's in num? Is it 1? No. Is it 2? No. Is it 3? Yes. So we extract into on order from the current cell, and now we can ask the question if the number of on hand is less than the number of on order. If it's true, then we take the current cell .style.color equals red and set num back to 1 and break, which sends us back to the top of the loop to get the next one until we're all done. And it works like a champ. JavaScript and numeric values. JavaScript has 7 basic data types, of which we only care about 2 at this point in time. Number data type, which is integers and numbers that have values after a decimal point. These are stored in an internal format. And string data type, strings of characters displayable on the screen. JavaScript is a dynamically typed language, which means it will perform automatic conversion between types as needed. For example, if you declare var num1 equals quote 30 quote semicolon, JavaScript treats this as a string because of the quotes. Var num2 equals 19.98, JavaScript treats this as a numeric value because there are no quotes and the format of the data matches the format for a number. Then if you code num3 equals num1 times num2, JavaScript will convert the value in num1 to be a numeric 30 and do the calculation, so the result in num3 is the product of the two numbers. But if you declare var quantity1 equals quote 30 quote semicolon, var quantity2 equals quote 141 quote semicolon, and then if you compare if quantity1 less than quantity2, alert, quantity1 less than quantity2, else alert, quantity1 greater than or equal to quantity2. In this case, quantity1 will show up as the larger value because JavaScript will do a string compare, and the first character in quantity1 is 3, while the first character in quantity2 is 1. On the other hand, if you declare var value 1 equals 30, var value 2 equals 141, then if value 1 less than value 2, alert, value 1 less than value 2, else alert, value 1 greater than or equal to value 2, will indicate that value 2 is the larger number, because JavaScript will do a numeric compare. As we saw in the previous video, you can use the number function to explicitly convert the value in a variable to be numeric. So in the first case, we could code if number of quantity 1 less than number of quantity 2, alert, quantity 1 less than quantity 2, else alert, quantity 1 greater than or equal to quantity 2. Then quantity 2 would show up as larger. So for compares, if both operands are numeric, a numeric compare is done. If both operands are string, a string compare is done. If one operand is a string and the other is numeric, the string will be converted to numeric. If such a conversion is not possible, the result will be nan, not a number. If it's possible with your data to have this situation, you should plan for how to catch and handle this error. For arithmetic operations, the numeric value of both operands are used, except for addition. The plus sign is the concatenation operator for strings, so if one operand is a string, the other operand will be treated as a string. For example, var val1 equals quote 5 quote semicolon, so a string, var val2 equals 6, so a numeric. Then alert, val1 plus val2 will display 56 because it'll convert val2 to be a string, and the plus will be a concatenation operator, so we'll have 5 followed by 6. So to do addition with at least one of the values being a string data type, you need to use the number function. In our example, alert, number of val1 plus val2 will display 11. Finally, for now, when you want to round the result of a calculation, you can use the toFixed method to specify the precision of a result. This is especially useful when working with currency, cost, price type data. We actually discussed this method in the lesson on cookies, but I thought it would not hurt to reintroduce it. Syntax, some numeric value dot toFixed parenthesis n. This returns the character string representing numeric value, including a decimal point, followed by n digits of precision. If n is omitted, 0 is assumed, and if the precision is 0, then no decimal point is actually included in the return string. Example, var rate equals 0.076, var basis equals 45123.50. Interest equals rate time basis, alert interest, and that will display 3429.386. And if I use to fixed to, then interest equals rate times basis dot to fixed to, or interest equals rate time basis, interest equals interest dot to fixed to, we see 3429.39. Note the rounding up. In this session, we introduced the DOM method, document.getElementsByTagName, pointed out the use of class name instead of class when referencing the class attribute in JavaScript DOM code, introduced the JavaScript switch and break statements, and discussed some features of JavaScript relating to numeric values, dynamic data conversion by JavaScript, the number function, actually a reprise of our discussion earlier, and the toFixed method, again a reprise of discussion that we had earlier. Coming up, in the next lesson, we explore the world of inline frames. See you there.